Good afternoon, ladies and gentlemen. We start the session after lunch. The topic is demystifying the potential of artificial intelligence and IoT. For this, we have our chairperson, Mr. Dinesh Sharma, Director, Standards and Public Policy, EU project. He'll be a bit delayed, but we have our rest of the speakers here. Our keynote speaker, Mr. Dhirendra Kulkarni, Senior Director, PTC. May I request you to come up on the dais, please? Speakers, we have Dr. Venkatesh, Sunkad, Mentor, INSOFE, Mr. Arnab Das, VP, Service Line Leader, Intelligence, Mr. Indraneel Banerjee. Mr. Banerjee, can I have you on the dais, please? Mr. Ranjeet Koul, Vice President and Country Manager, Aeris. Mr. Rahul Ganapathy, and Dr. Hemen Goswami. We have Mr. Chandra, who will be here within 5 minutes. He's on his way. So we'll just give a 5 minutes. Then we have our chairperson, Mr. Dinesh Sharma, Director, Standards and Public Policy, EU Project SESEI. May I request a bouquet of flowers for our chairperson, please? And a bouquet to our keynote speaker, Mr. Dhirendra Kulkarni, Senior Director, PTC. Now I hand over the mic to our chairperson to conduct the session.
Welcome back. Sorry for being late. As usual, it's Delhi NCR traffic. I did not thought so, but it happened. Nevertheless, let's not waste any more time. We have one keynote speaker, and after that we will begin with the session. But as I said, thank you very much. Welcome back. It's post-lunch session, always tough, but maybe some excitement has begun, me being late. So without wasting a time, let me share with you that this session, which is dedicated to demystifying AI and IoT, we believe it's going to be an interesting session because this is not a technology which is a technology for the future, but it is present, but it brings a lot of potential for the future as well. And I'm confident that you all will like it, and the session will prove to be stimulating enough to keep the intent alive. And we will begin with our keynote speakers, Mr. Dhirendra Kulkarni from PTC, and before he shares his presentation, let me attempt to briefly introduce him. Mr. Kulkarni is a pre-sales senior director, managing technical team for PTC India. In his role, he engages with customers, prospects, to understand organizational goal and business initiative and help them in understanding and building digital transformation roadmap, aligning with the Industry 4.0 and PTC technology solutions and platform that helps customer to transform the way the products are created, manufactured, operated, and serviced. He has overall 25 years of experience, of which last 13 years have been dedicated towards PTC. He has earned a bachelor's degree in electrical and electronics and engineering. And Mr. Kulkarni, I request you to please share your perspective on the topic, please. Thank you.
Okay, good afternoon, everyone. So as Dinesh said, it's a little bit tough after post-lunch, but I'll try to make it more interactive. And of course, it's the panel discussion will be followed by this. So today, I just maybe 10 minutes or max, another 5 minutes, maybe 15 minutes max. So I'm going to talk about a little bit of how we basically some concepts, a few new technologies that are part of this IoT and AI today. As he rightly said, it's not the future technologies, but currently they are already existing, and how we can really use that in a current industry scenario is what I'm going to talk about. So let's start with this. So basically, there are two words, right? The digital world and the physical world. Traditionally, you see these two words are disconnected with each other, right? So if I just want to give a quick analogy of this, in the digital world, if you see, there are different technologies, like many of you come from a manufacturing industry, and you know the CAD, the PLM, the ERPs, all these digital systems are used to, Yeah, it's better. That's better. I can go around here. Okay, so there are fundamentally two worlds, the digital world and the physical world. And traditionally, just think a world before the invent of the IoT and before Industry 4.0 and all that, maybe 2012, 2013 time frame when this IoT was still not there, right? So these two worlds were not physically or not fundamentally connected. They were disconnected. Like example is like, these are some of the technologies used to design or create a product, okay, and then manufacture that product. And once the product is in the field, then it goes into the physical world, and then that's it. There was no way to get the data back from that world back to the digital world and understand how whatever I had created based on certain assumptions and past history and all that, how my product is behaving under different geographical conditions, different parameters. So there was no way to really understand. So all that, when the product fails, somebody has to go to the field and do some analysis, do some postmortem and take that data and try to do analysis based on that actually. So as a process, there was no way that these two worlds were connected, and there was a continuous process of exchanging data between these two worlds, right? So in 2013, all this invent of IoT, Industry 4.0 all started, and thanks to the technology improvement, and with that, we got into IoT. So basically, what IoT is, as the name suggests, Internet of Things, basically connecting the things over an internet and get that particular data. It's as simple as that. And then, of course, what you do with the data, there are numerous possibilities what we do with the data and how do we use that data to improve our day-to-day life. So here is a simple picture what I put here as an IoT. It can be a product in the field, like it can be a car, it can be an aeroplane, it can be a truck, it can be a machine in the factory, or whatever it is, right? So because of IoT, because of the connectivity, sensors, PLCs, so it's that product is smart and connected through a connectivity, and we start getting the data and start understanding the data and start using the data from the product development, quality improvement, cost improvement, service, and there are so many possibilities which I will talk about a little bit later, right? So that is what IoT has done. If you see the pre-IoT and the post-IoT, where these two worlds were disconnected, and with this technology, now we are able to get the data and start make using of the data. It's as simple as that. At the same time, there is also additional technologies which are part of this fourth industrial revolution, which is like a mixed reality, which for a particular I'll talk about augmented reality, which takes the data from the digital world back to the physical world. Like if you see this particular picture, it's a Caterpillar genset, where this particular service technician goes to the genset and puts his handheld device like iPads or phones or any phones or even the smart eyewears, and when he scans that particular barcode on the physical device, the entire digital data augments on the physical device, and you get that entire data as if you are sitting in the factory and getting that entire 3D data right in front of you, right? And then of course with that data you can actually do a service, you can do a maintenance, you can do a training, we will see a lot of other use cases. So these two technologies like an IoT and augmented reality has really helped us to bridge that gap between this physical and digital world, and ultimately today as we speak, these two worlds have converged, right? And when these two worlds have converged, it opens up all new possibilities from the business standpoint. We will see a little bit of that. So what I want to talk about in the next 10 minutes is basically not all about concepts of all that, but how this IoT, AR, artificial intelligence really helps us in our day-to-day life. I'll talk more from manufacturing perspective, from industry perspective, right from engineering to manufacturing and aftermarket. In all these three areas, how these technologies play an important role, and they transform the way that today we work in terms of designing, in terms of manufacturing, and in terms of the way we service or we train and we maintain those particular products. So let's start with an engineering. So there are three areas. Of course, there are many areas in engineering where this technology has an impact, but I'll just talk about three areas. The first one is a design. So traditionally you start with a concept design using your 3D CAD softwares. But when you do it, even though with a lot of optimization, a lot of things you can really optimize the design. But today, even right from starting the concept design, the artificial intelligence has started coming into these technologies itself. So I'll just give you this particular example, which it will say that how do you create a generative kind of a design with AI propelled designs, right? So in this example, it's a small component with some holes, 4 holes there, and the shaft in between. And of course, as a part of the regular design, the designer will give some constraints. in terms of maybe the boundary, the forces, the material, what kind of material is to be used and all that. But in a normal days, what happens is when you give those kind of a constraints, those kind of parameters, those kind of boundaries, it will generate you a most optimum design and give it to you. That's it, right? But with AI now embedded as a part of this concept design technology, this is part of PTC's Creo suite of solutions, 3D CAD, which is used for product design. Right here, it just not only throws you one design, which will you see now, like once you identify those, because we don't want to move the boards and all, but now you see the different shapes, right? It's basically the AI engine built into this particular CAD technology is now providing you the ideas that, you know, with these same constraints and conditions that what you have provided, various design options are possible. It's not just a one optimum design, but there are various possibilities. Okay, of course there is a lot of technology or technicality behind it, but just to give you a thought that, you know, how AI can play a role in the design by guiding you with various design options and you know, choosing the right and the most optimum option is the first part of this. Then coming into the simulation part of it. Now, this example, if you see, as the race car is going around the track, we can actually create a digital twin of this and actually get a real-time data and you know, simulate that in a digital world and actually check our design based on the real-time data instead of maybe we would have designed based on our assumptions or past historic data and all that. With this digital twin concept and having a sensors and connectivity from the car and getting that into a digital world, putting that data into simulation and actually see how the things are behaving into that. Again, this concept is called design for connectivity, where you can actually design keeping this in mind in connectivity and getting the data. So this is another example how on a real-time basis we can actually simulate, use AI and IoT in day-to-day life, right? The third part of this is now I'll get into manufacturing a little bit. So in manufacturing is where I think you must have already read a lot about IoT and the impact, the economic impact, that economic business impact that, you know, this IoT is going to have in this world. And maximum one third of that economic impact in the IoT is coming from manufacturing. So there is mostly 30% of this overall business that what IoT is going to provide is coming from manufacturing, that is from industry. So that's what we call as Industry 4.0 or smart manufacturing, right? And we also see a lot of traction in India in making the factories of the future or smart factory and all that. So from that perspective, again, IoT, I think analytics and AI plays a very important role in manufacturing. Here on the left hand side, if you see, I've just put some screenshots where you can actually make the connect the shop floor, the machines on the shop floor with the PLCs and all that as a part of our Industry 3.0, which is already there with robotics and automation. But now what Industry 4.0 does is one step beyond that, you know, taking the data from whatever at collection points, whether it's a PLC or historians or SCADAs, and take the data from those systems to an IoT platform and provide you a centralized kind of a dashboards to give you the data insights and then of course do the analytics and things like that. So I'll take you a little bit more on these screenshots. For example, this is a tractor manufacturing company spread across the globe. You can see where are those companies and what is the overall production and all that. So next slide, if you see again, what is the overall equipment effectiveness of that factory in terms of key parameters like performance, availability, quality, trend analysis, how the different parameters are behaving under different machine over a period of time during a day, so that you can do some analysis and take some course correction. And you can also see here some of the reasons for rework or downtime of the machines and all that, which can be used again for as part of the analysis. So this is an automatically captured data from the machines. The further, if you go further, more dashboards in terms of plant-wise, line-wise, and things like that, under each line or different sub-assemblies, how the analysis can happen. Then going forward, this is another screenshots where we can also get a lot of data from business systems. As like we talk about Industry 4.0 is not just connecting the machines and capturing the data and measuring the OE and taking the predictive maintenance of the machines, but it's also giving an insight from a different business systems. For example, in this particular screenshot, if you see, there are certain columns, certain data that is not coming from the machine, but they are coming from a business systems like ERP system, from an engineering system like PLM systems, right? Because you need a data from different business systems also, which will get mashed up with the machine's data to provide you a more sensible data from the analytics perspective. So that is another example where IoT not only interacts with the machine, but also interact with the business systems and get the data together and provide you the better analytics. Okay. Now, slowly moving from machines, OEE, and breakdown and all that, to another technology that is coming in the manufacturing as a part of this IoT, AI, and Industry 4.0 is augmented reality. Now, this augmented reality is transforming the way the assembly is happening at the shop floor from the traditional way how it is happening. So this, you can just see this particular video, and we will understand that how these things are changing from manufacturing.
We came along and we had a mixed reality solution to allow them to create experiences for the HoloLens quicker and more efficiently. It's all drag and drop. You don't need a lot of technical expertise. You can get up and running right away. Just makes it a lot faster and easier to get a lot of people using the experiences that were created with our software.
PTC's mixed reality solution has allowed us to drag and drop our 3D models that we already have to create guided work instructions to deliver to our production floor in hours and at a tenth of the cost.
We develop a step-by-step guide that lets the assembler completely assemble the battery.
You're not looking at this in 2 dimensions anymore on a screen that's far away from you. It's right in front of you.
The HoloLens has really become beneficial in allowing us to train new people on this product 30 to 40% more efficiently.
Using the HoloLens, I was able to cut my assembly time in half. We can understand and we can learn so much faster, efficiently, feel a part of this process.
Microsoft has really nailed it with the HoloLens platform, and PTC is helping us scale this affordably across the enterprise.
20 years ago, we didn't have personal computers on every bench. 10 years ago, we didn't have 3D printers. Now I can't imagine building without those. And I think this is what the HoloLens represents. It's the next step in the evolution of high-tech manufacturing.
The future of mixed reality is really exciting because the possibilities are endless. We're just starting to scratch the surface of it.
It really is endless what we're going to be able to do and where we can go. This is going to help us get there.
So if you heard about it, 30 to 40% efficient in manufacturing assembly using this augmented reality, right? So all the digital instruction coming right there, so you can look at it and then assemble instead of looking at the process sheets and documents and things like that. So that's a new thing that's happening in the shop floor and assembly as part of this Industry 4.0. So another very interesting video, this is how augmented reality can also be used from the quality perspective.
Nous innovons avec immersion en utilisant la réalité mixte pour répondre à un besoin concret. Le contrôle qualité moteur sur notre ligne de production Renault Trucks à Lyon. L'idée est de permettre aux opérateurs d'avoir sous les yeux des instructions d'aide à la décision pour réaliser leurs tâches les plus complexes. Le prototype est maintenant finalisé. Nous passons au pilote en usine et visons une industrialisation d'ici 2019-2020.
Aujourd'hui, quand on contrôle un moteur, on a une checklist imprimée. Avec ce nouvel outil, on n'a plus besoin de papier et on a les mains libres. Une fois qu'on s'est habitué aux lunettes, c'est très intuitif et ça aide vraiment à être plus efficace et à se focaliser sur les contrôles les plus complexes.
Quality is fundamental for our business and very well recognized by our customers. Augmented reality will bring some practical applications in the plant to help us to improve even more the quality for the products that we are delivering. For this reason, as the director of the engine plant, I'm encouraging this implementation of this new innovation. This will place us in the new digital area of development, the Industry 4.0.
Yeah, that's example how again from manufacturing to quality also can be checked using this. So moving forward, we talked about engineering, we talked about manufacturing. Now we're getting into a service or an aftermarket, which is again a very, very important field, and how do we really give that digital experience to the field technicians, service, or even to the customers themselves, right? So there are 3 areas where I put it, where the IoT, artificial intelligence, augmented reality can play really a good role is in the service, predictive maintenance, and also the training. So let's very quickly look at each of these. This is about the service. And here if you see again this gentleman going and scanning the barcode there, and there is some fuel blockage on this. So again a digital representation is done on a physical device, and he knows exactly where is the fuel blockage, and if he needs to replace the fuel filter, the disassembly and assembly sequences are inbuilt into it. How to replace a filter is a very easy step-by-step instructions are put into here, and that's how very easily service technician just go and do that. Okay. So now moving forward, in the interest of the time, this is another small minute video on predictive maintenance, right? Analytics, how analytics is important, plays an important role here. This is, for example, a flow serve pump, which circulates water used in the oil and gas industry. It is retrofitted with few sensors and of course a very high computing computer into this. And in this example, is just closing the wall so that the circulation stops, which automatically has an impact on the pump in terms of that impeller and shaft. So because of the machine learning and artificial intelligence inbuilt into it, it understands the anomaly detection and how the abdominal behavior of the pump, and automatically you can see that how it is flagging the pump efficiency going down, the pressure increasing, and also the impeller at risk, and in fact to the extent of saying that it is 5 days to failure. Like if you don't take any action within 5 days, this is going to fail, and it's a big loss in that line, and it's a huge impact on the business. And when you add augmented reality on the top of the IoT, here you can see the sensor information coming as a part of the digital representation on the physical device, and also along with those alerts where there is misalignments or low flow and things like that, where automatically a technician can understand and take a corrective action immediately based on that. So that's another example how predictive maintenance or service can be totally transformed with using these kind of technologies. Last is also is very important. Even though with these kind of technologies, with those kind of experiences inbuilt into it, you still need a kind of a remote assistance to carry on the service and maintenance operation. In this, there is another example where he just do a call. It's similar to kind of a WhatsApp call, but the difference is when a service technician tries to do it, he may not understand. Even with those animations created, he needs some kind of a remote assistance where person is not really right there, right? So remotely he can tell him with some kind of annotations which button to push or what needs to be replaced and things like that. And of course this knowledge can be saved later on to use it for further operations or as a reference. So there is also remote assistance again coming from this. So I'll just skip this. So this is my last slide. We just have to summarize this. So I just spoke about the physical digital convergence to begin with. When there was no IoT, no AR, when these two worlds were not connected, we were not having the opportunity to use the data and do some insights and understand how it's happening and things like that, and change the way we design, manufacture and service. But with IoT and augmented reality, now right from if you see connecting the device with sensors, PLCs, internet connectivity, and taking that particular data and then dividing that data into context, like from a maintenance perspective, from a production perspective, from a design perspective, putting the data in a role-based way so that it makes sense of it. Then the third part is basically doing the analytics, whether it's a descriptive analytics, anomaly detection, prescriptive analytics, predictive analytics, all of these, some of the examples which I show, those kind of analytics you can do. If required, you can also orchestrate certain things, like if you want to send a software patch or do some file transfer between the two machines, we can do that. And finally, with augmented reality, we engage and complete that particular action. So that is how the entire, this Industry 4.0 technologies is changing or transforming and playing this important role across the product life cycle. Just to conclude, I'm from a PTC. PTC is a $1 billion company, and you saw that physical digital convergence, right? It was an yin-yang diagram, basically a Chinese yin-yang diagram, which says that when two opposite forces come to each other, it complement each other actually. And our PTC logo is also based on that particular principle. The white one, you can see it as a P, and the green one as a D. When this physical digital world converge, and it opens up new opportunities and new business potentials actually. So it's based on that. And on the right hand side is our headquarters at Boston. And PTC, I'm not sure how many of you already know, we were traditionally into CAD and PLM, into the engineering world. But in order to close that loop from physical to digital, we invested into IoT, acquired few companies, and the new technologies, augmented reality, virtual reality. And today, we have all of these solutions, both from platform as well as from engineering side. So that's it from my side. We have a booth in Hall 7B, booth number 35. And all of these technology, what I showed you, you can actually experience that live. We can talk to the experts there. So I request all of you to please come and visit us and discuss more on these technology solutions and how we can support you to implementation of this Industry 4.0. Thank you very much.
Thank you, Dhirendra. You can have your seat. Do you have any immediate questions before we begin the panel session? Maybe we can have one. Questions to Dhirendra. If not, we can take it up in the panel session. I see no hands, so maybe we need to give them more so that we can pamper them to ask the questions. So let's begin with our panel. And before I begin with the panel, Maybe at the end of it, I thought of giving a presentations, what's happening in Europe. But maybe in the context of the time, I'll see if I could get some time at the end, because I have not copied the presentation. But let's begin with the session and session's theme, which is demystifying the AI and IoT. And I think broadly, with Dhirendra presentations, we could say that it's not a technology of the future. It's there today. But yes, it brings a lot of potentials when we talk about from a deep data analysis point of view, big data point of view. Because at the end of it, when we talk about IoT, sensorization, or an artificial intelligence, it's playing with your data. And data is going to explode. I mean, it's like a next oil, you know, for all the countries. So it's there today, but yes, we still say it's a technology ready for the future. It will bring a lot of benefits, see it from an industrialization point of view, because everybody probably talking about AI more from a digitizing the industry. You name it, it could be Industry 4.0, or in Europe they call it digitizing European industry, or people say smart manufacturing. So it's starting with that, but I think it has a lot of potentials, because every vertical segment, when it marries with the Internet of Things, every vertical segment will bring its own benefits by using a technology called AI. So I think with that as a context, let me begin with our panels. And I think we have sync in, so maybe I'll begin with the panel introducing each of the speaker and requesting them to share how their company, how their product portfolio could help us, all of us, including our delegates, to demystify this AI and IoT. So with that, let me begin with our first speaker, which is Dr. Venkatesh Sunkad, mentor INSOFE. Dr. Venkatesh Sunkad has 20 plus years of experience, industry experience in telecom, cable, wireless, and IoT industry. He currently works at INSOFE as a mentor specializing in the IoT and Industry 4.0 focus area. His responsibilities include training, consulting, helping industry and businesses in various technology and strategy challenging areas. Previous to this, Dr. Sunkad was associated with Mobilium Incorporated as the Associate Vice President of Technology, responsible for product management and technology vision for the company. He has also worked with Vodafone as a GM for strategy and architecture, and Viasat Communications USA as a Director of Networking Technology. Dr. Sunkad is MBA from University of Denver and Masters in Electrical Engineering from University of Texas and Doctorate from University of Colorado. He has been featured as a top 50 cable technologist in Cable Today magazine, has more than 30 international talks and publications. So Dr. Sunkad, in your views, what do you think is the potential of AI and IoT and how we can demystify it?
Hello. Can you hear me, guys? Yeah, great. Hey, thanks, Dinesh, for a good introduction. And thank you all. So just wanted to talk about, for Industry 4.0 and IoT. But before do that, let me spend a minute saying, how did we get to Industry 4.0? So basically, because everybody talks about Industry 4.0, but basically there has to be a 3 and a 2 and a 1 before you got into 4. So let me start with that, and then I'll talk about how India can play the role in it, because end of the day, whatever we talk, it has to be India specific, because that's the way it is. So if you look at the history of mankind, right, Industry 1.0 was basically the first time when the steam engine was actually invented. So what happened when the steam engine was invented was people could now move things a lot more. So the producers and the consumers need not be in the same place. And that's what actually Industry 1.0 happened. The second Industry 2.0 was when electricity and mass, manufacturing or assembly line was invented. With electricity, what happened? Technically, you could actually make it 24/7. With mass, production or assembly line, things could be produced a lot. The first and the third revolution is what actually we're going today, which is the internet, the whole, IoT, and the whole, that was Industry 3.0. There's a lot of data that was generated in 3.0 that actually is being used in 4.0. So what is Industry 4.0? Industry 4.0 is basically two things. Using the data that has been generated, how do I smartly use the data to do certain things? And the second thing is, how do I make it more efficient? So that is sort of the history of Industry 4.0. If you look at it, India didn't participate in 1.0 or 2.0. Yes, they did slightly in 3.0, but we should not miss 4.0. So now coming into IoT, what did we do in IoT? So if you look at the way the India has been done, very important that from an IoT perspective, if you look at, again, 1 minute and then I'll talk about, how it's been in the journey. 1990s is when the internet actually, for the commercial part of it, even 60s, DARPA and everything, DARPANET and everything was there. 90s was when actually the internet took over. So that's when you could have the static pages, where you could do it. And I call it the Internet of Pages. After Internet of Pages, where basically it was a one-way communication where you could just receive information. From that, we went into second thing, which is called the Internet of Systems or Internet of People. That's when, the financial people started, hey, can I do banking technologies? Can I do things like that? The second thing was the social networking happened. So that I'm calling it the Internet of People. The third part, which is actually the Internet of Things, is when machines started talking to each other. Humans and machines started talking to each other, and missions started talking to each other. So that is sort of the Internet of Things, that's what we are today. From an India perspective, and this is very important that we talk about this, there's a lot of technologies that are happening, but we have to find solutions that are India-specific. And so in India specifically, there are 3 areas where IoT is really taking off. One actually is in the health sector. There's a lot of innovative solutions are being done in the health sector, and I'll give you 1 or 2 examples of what's happening. The second sector where there's a lot of work has been done is in the agricultural sector, and I'll also talk about that, where actually we're finding India-specific relations. Third one is the smart infrastructure we talk about. So the first one, which is actually in the health sector, what they're doing is there's a lot of startup companies are actually doing. I'll give you a couple of examples where and I was talking to a couple of the panel members before this. Actually, what they're doing is they're having these machines. For example, unfortunately, especially in the rural areas, tier 2 or tier 3 towns, there's a lack of, should I say, doctors, ophthalmologists and actually doctors of ophthalmology. So they have these smart machines which you can train anybody. All they do is go there, get the complete eye scan done, and the complete thing is in the cloud. Now, the doctor need not be at the tier 2 location. He can sit in Delhi, Mumbai, or Calcutta, and you can get the best doctor looking at the scans. Similarly, they're doing it for pathology, where they're actually doing the pathology scans and putting it on the cloud. So these kind of innovations are very critical in terms of making India this. Smart agriculture, there's a huge amount of things are happening, especially for fighting diseases. In Punjab, there was a very big, where actually they used smart agriculture in order to know how do I fight diseases. So agriculture is another one. Third one, where actually we are doing some projects, we're doing some consulting, is in the infrastructure divisions, where actually, they want to track people in terms of, how do I know actually when a construction worker says he's in the second floor, as he or she is in the second floor, things like that, which are, sort of generally an India or slashly, sort of an Asia-specific, solutions, which I think is more required, I think, for it to be done. Thank you.
Thank you very much. Okay. I think you hear it, that the application of AI is beyond manufacturing, and few sectors have been highlighted from an Indian perspective, be it smart agriculture, healthcare, infrastructure. When you talk about infrastructure, it's a lot. I mean, it could be a smart home, it could be smart cities in India. So there is enormous applications where you could implement this AI. Just before I move on, in EU, a study was carried out, and as per this study, almost 57% of the companies expect AI to have a high or very high impact on business areas that are entirely unknown to the company today. It means the companies, a lot of companies have a data, but they don't know how to make use of it. And today's efficiency could be doubled if they start using a technology like AI. So it has been proven from the survey, and it was also highlighted by Dr. Venkatesh. So I think it's a reality. And it's not a new technology. I mean, for example, in EU, in year 1982, they established an association, they call it EURAI. I mean, you can Google it and you can find out all the information. Since 1982, an organization exists which has been doing research and innovation, developing a platform. It's an open platform, people can come and play with it. And that's how this technology was existing, but it was not in use because, like, for example, Industry 3.0, the data was there, but we did not know how to make use of it. But now we know we have a data and we can make use of it. With that, let me move to our next panelist, Arnab Das. Yes, Arnab. So let me, he's Vice President, Service Line Leader, Intelligent IoT and Edge with Aricent India. So let me introduce you before you could ask, I could ask you to share your views. Mr. Das heads Aricent's IoT product and services business and ecosystem partnership that delivers IoT solutions to a global clientele. He has 28 years of rich experience in telecommunications and the software industry. Arnab has worked extensively in product development, product management, design, and rollout of managed services offering for various verticals. Arnab has been involved in business development for 15 plus years, where he has addressed diverse markets comprising global OEMs and CSPs. With that, same thing, same question to you. How we can demystify the AI and IoT, and what potentials it has with it. Thank you.
Am I audible? Okay. So to demystify, you have to be mystified with it to begin with. There's a little bit of that mystery, particularly outside in, and even for most of us who see a lot of this in our solutions and problem statement addressing. What can AI do for you? There was a very interesting point that you were making. AI is oil. The second part to that statement is if data rather is oil, AI is the engine which runs on oil. All that data that industry computes and churns out and generates, for example, a connected car on an average would generate a petabyte of data in an hour. That's just one connected car, to perform all its algorithms that it needs to in an automated manner for the car safety, for car to infrastructure, communication, controlling the traffic lights, or receiving information about environment which is required to run the car in an automated manner. All of that, it's about a petabyte of data, and there could be millions of such cars in future. So clearly, expert systems, storing data in big databases and extracting it, and writing programs which are designed on a set of rules is just not enough to be able to handle this kind of data in an intelligent manner, which can draw inferences. And this is where the systems of AI, which is not very new, as you pointed out, it's been around for decades, it's been tried out in different contexts, but it is only today, in today's environment, that we have the ability to create models which can learn, and this requires intense and immense amount of compute power. And this is where, tensor operations which you need to compute very rapidly to detect with an incoming stream of data what is going on, to make some inferences and then recommend some actions. This requires a lot of complex computation inside algorithms, which today's hardware environment, processor advances is able to provide. And this is why you see in a lot of the examples that Dhirendra showed, all this is enabled because of availability of this compute. Any one of those transformations that he was showing in assisted manufacturing, that if you recall, there was one example that he gave, that the technician is going in front of that Caterpillar equipment. And notice he did say that before this application could work, somebody would have gone out and put a tag on each one of those Caterpillar devices so that you could go and scan. Now in an utopian AI environment, maybe not so far away, you could go and point your camera of your device on a machine which has not been tagged. That is the challenge, right? Now the algorithm which is running, the image recognition algorithm, you can train it and download it on that iPad device over the air, and it can go and learn to detect a new machine and trigger it back to the network, and then the network tells, okay, this is the operational parameter. So that important step of programming the source of data a priori is not needed when you can implement a true AI system. So the flexibility that models can give in interpreting data which is not pre-programmed into your logic or application is very, very crucial, particularly in IoT, sheerly because of the diversity of the use cases and scenarios, and sheerly because of the volume of data that is required or that is generated from devices in a production environment, in automotive, in healthcare, and in any industry. So, so that is why you see a lot of engagement in the industry around what can AI do, what is AI. Of course, IoT is one area of AI. You can take AI and talk in context of finance and talk about trading models and predicting, maybe in someday it can predict if the stock market's going to crash, maybe some of those or swing wildly up. But certainly that, now there are, of course it is not a panacea. AI models need to be trained. The model themselves, you need to decide. There are aspects like feature engineering or supervised versus non-supervised learning and so on and so forth. But then the industry is making, with academia, as it so happens in most cases, is making immense progress every day. And that is why you see smarter and smarter systems and surprisingly accurate models which can come out and interact with the, I'm sorry, I really apologize, should have put it on silent, which can interact with the target environment and react to extremely varying signals and create outcomes which are meaningful for the business, which are meaningful for that particular organization which is deploying it. So I've touched upon a few things. Obviously, these are very extensive and deep discussion topics, but AI and machine learning and deep learning are many similar terms. There are nuances in each one of them. Are the technologies to track, no matter which industry you belong to, it is going to be an important tool for you, and it's going to impact you, all of us, in more ways than we can imagine or started to imagine even today.
Thank you, Mr. Das. I think we heard, we are sequentially connecting, you know. Dhirendra showed the possibilities, Dr. Venkat showed the data availability and the IoT evolutions, and now you're saying on top of it, the processing. I mean, now the processing has become possible, and that's why we are able to talk about more in artificial intelligence. He did touch upon the challenges, but let's park on the challenges because challenges are there, and we are learning every day when we talk about a technology like AI. That's why, again, I'm sharing with you what I had prepared presentations in between before I go to the next speaker. So the second point I would like to highlight in EU is they have prepared a strategy and released it last year. And it does touch upon the challenges which Mr. Das highlighted. They are addressing 3 verticals. One, they call it boosting technological expertise and industrial capacity through a public-private partnership, but the challenge which he said is more to work on the social economical challenges. When you say socio-economical challenges, there you talk about skill enhancement, trainings, educations, because AI will be applied in those verticals as well. But we need to learn about it. We need to learn about the ethics, how to take care of the ethical part of it. It could be misused, because today you see a lot of videos which is using artificial intelligence and then wrong kind of applications and solutions are getting built on top of it. And that's where the OU is also focusing on this as well. With that, let me move on to our next panelist, Mr. Indraneel Banerjee. Mr. Indraneel Banerjee is partner at McKinsey and Company in Bangalore, where he leads the firm's business technology work in Asia. With a focus on designing strategy and operating model for core technology, Indraneel serves the banking, high-tech and telecommunications sectors in India, Australia, and the United States. Example of his recent work include helping clients to improve the efficiency and effectiveness of their IT spend. Prior to McKinsey, Indraneel was a partner at TPI, a subsidiary of ISG, and the largest sourcing data and advisory firm in the world. Okay, so with your vast experience in banking, ICT, and telecommunications, again, I may request you to please share with us your views about the AI and IoT and how to demystify. So we stick to the same question, and then we'll have additional questions later. Thank you.
Thank you. Let's do a little bit of framing about how big this opportunity is. So just a show of hands, how many of you walked from your house to Pragati Maidan? Show of hands. You walked. Okay, one, good. Anyone rode a horse? Thank you. How many of you got into a vehicle which had an engine, an internal combustion engine? Truck, bus, okay. So that's like 95% of you, right? So till we reached what you heard as 4.0, the single biggest change that happened, perhaps, for us as a society is actually the internal combustion engine. In the last 150 years, it's added 1%, 0.5% to 1% per annum to global GDP, which essentially means that it has doubled the entire wealth of the world. That's how important it is. Artificial intelligence and IoT will create the same impact in the next 20 years. Just for perspective, it's that big. McKinsey Global Institute research shows that IoT alone will add between $4 to $11 trillion to the world economy. Just for perspective, that is 10% of all of the world's economy. It means it adds Japan's gross value to the economy. It's that big. Where will this happen? It's going to happen in 6 sectors: automotive, healthcare, shipping, retail, auto, and public sector. And in some sectors, IoT is essentially going to be the only play. It is not a play. It is the only play. Let's take auto. In auto, in the next 5 years, 46% of all value, anything you did, you could invent, you could brand, you could create new cars, you could do anything. 46% of value is going to come from IoT. What does that mean? It means that Tesla, all of us have heard of Tesla, which has 1% of the sales of General Motors, just 1%. GM is 100 times bigger than it, has a market valuation which is higher than GM, which is higher than Fiat, which is higher than Ford, right? So that's the size of impact that companies like this will have. The second, 6 regions will capture 80% of this value. India is there, but India is the 6th. We are going to be 4% of the total value. For framing, China is going to be 4 times bigger at 17%, and we'll talk about why. The third, when we think about IoT, most of us think about connectivity. Connectivity is table stakes. That game is over. 2/3 of all the value is going to be in software and services and analytics. What you do, as you were hearing from my esteemed panel members, what you do with the data, how you connect, how you free the interactions, that is basically going to drive the value, right? So first message, huge opportunity. The second, how are we doing now, which is almost like your report card, which is very interesting. 8 days back, we presented at Davos. McKinsey presented on Industry 4.0, what is the health of the industry. On one hand, if you look at the technology play is coming along very, very well. On connectivity, we have 8.3 billion IoT devices, more than 1 device per human being. The future is the future of the things. The second, connectivity, in terms of what kind of intelligence is coming out of it. 90% of all data that exists today was created in the last 3 years. 2,500 years of human existence, 90% of it is last 3 years. And it's just increasing. The third is automation. 60% of everything we do today can be automated using technology that is available now, right now, right? So that's the technology side. But when we went out and checked with industries how they are doing, only 30% of companies are doing IoT at scale. When you come to ASEAN, that number drops to 13%, 1-3. We are in pilot paralysis. And if you look at India's report card, India has a proud number, 10.6 IoT pilots per company. but we are not progressing to actually deploying it. So most of the very cool videos you see, most of the very cool setups you see are actually at pilot stage. We are doing it with 200, 500,000 people. We are not hitting the 10, 20, 1 million people at a minimum we require for impact, right? So what have we learned? In our research, we've learned that there are certain lighthouse companies, companies that are doing it well. And there are 3 things that they are doing consistently well. The first is you have to strategize the process. In this hall, you'll hear that it's about technology. That answer is incorrect. It is not about technology. It is about business. You have to go value back. You have to show that there is real money in it within a finite amount of time. And the moment you show it, you have a use case that pays for itself. One of our 16 lighthouses, Hire, in the Qingdao plant, essentially changed their entire sales process. Instead of selling through retailers and distributors, they went online, B2C, which means if you order an AC from the Hire plant, you order it 100% online and you customize it. Every AC sold that's manufactured in that plant is actually customized by an end customer. And in the back-end, IoT-enabled factories churn that out. It's resulted in the turnaround time dropping by 35% and productivity going up 2 times. Rolls-Royce no longer sells engines as an engine. It sells time on wing because they have IoT devices embedded in the engine. They rent you an engine like an Uber taxi. They rent you that engine because they can run the engine better than the pilot and the airline that actually runs the aircraft. They saved $500 million last year, and they take a percentage of it. So the first one, strategize the process. It's about the money. The second, innovate your infrastructure. It's not one layer. Most of you see the cool front end. If you need to be successful in IoT, you have to cut across the board. And one of the things India struggles with is a uniform approach of going right from the front end to the back end. Unlike China, that has basically created a national code that people follow, right? So huge differences in terms of how you do it and how open sourced it is. Successful companies, lighthouses in our database, are 1.75 times more likely to use technology that any third-party developer, any, can build on top of. It's a team sport. It's not you winning. It's really how many people in your ecosystem can you build in, and how attractive can you make it. And the third, I think you heard this, it's about mobilizing the organization. It's about people. Because the skill sets you require are different. Tata Steel, in their Ingenuid Digital Academy, when they looked around and they said, we need digital, the first thing they looked at it and said, anyone who's senior does not know digital analytics. That was a stark assessment they made. In 4 months' time, they trained 200 managers on digital and analytics. Together with enablers, Tata Steel's EBITDA in that plant went up 25%. 25%, right? So just to synthesize 3 big themes. First, the opportunity is massive. It's possibly the biggest opportunity since building the engine. However, it's hard to do. Only 1 in 8 companies are getting it right. Only 1. And to do it right, you've got to follow the money. You've got to think full stack and ecosystem. And you have to get the right talent to be able to play. Thank you.
Thanks, Indraneel. You heard him, how much potential it is there, how much it can contribute to the GDP. Even if connected cars are not a reality in India, you can begin the story by intelligent transport system, then move it slowly. He also covered about the challenges like skilling. 8 billion connected device, I think the journey has begun. Probably many companies are into IoT field, but 10.8 is not enough. When we talk about 20 billion connected device, we know the potential it can bring. Probably I work for a standardization, and that is where we are trying to help them out. People get scared about it, that even if communication technology exists, do we have a standardized technologies? So we work on the platform, so I'm a standardization expert as well. But nevertheless, let's park it, because I would like to give some time for our audience as well. And she has asked me, so I've asked her 15 minutes extension, so our session will end from 3:45. Let's begin with our next panelist, Mr. Ranjeet Koul, Vice President and Country Manager, Aeris, APAC and MEA region, India. During his 20 years, Ranjeet has had a strategic positions at various organizations of repute like Intel, HP, and Tata Avaya. Before this role, Ranjeet was Regional Manager APJ at Intel Technology Consulting and Business Development Function, where he directed and activity engaged in APAC Technologies footprint. Electrical engineer from BIT, holds MBA from University of Phoenix. Ranjeet is an active member of IoT. We work together on that. IoT panel for India. Mr. Koul, your views about demystifying AI and IoT.
Thank you. There's a slight disadvantage of being sitting left to a doctor and then talking after a person who's a partner at McKinsey. But I slightly disagree with Indraneel on the connectivity part. But let me park that for a moment. I will take you back to the semiconductor stuff. The maths that dealt with data, it was always there. Being an engineer, being a math student, it was always there. The problem was always, where do you store that data? And the biggest innovation which people missed was when the hard disk, a simple thing, hard disk, changed from an optical stuff to an SSD stuff, wherein you could store data and create data lakes. That was the biggest innovation, and that gave boost to the industry that we're talking about today is IoT and AI, because it's all based on data. So now shifting gears to the connectivity, if you look at what is happening, machine to machine is a very different paradigm when you talk about connectivity than when you talk about connectivity on phones or lease lines and something like that. And 5G, which is on the door, is going to create a huge, huge difference in how machines are going to talk to other machines. I think that's going to create a new paradigm for Internet of Things, how machines talk to machines and how we get the analog data and we convert that back into digital stuff. And I completely agree. The opportunity is huge. At Aeris, we are a machine-to-machine connectivity provider, and along with that, we also provide platforms and softwares for all kind of IoT applications. So in today's world, today we manage some around 10 plus billion IoT messages per day. That means 10 plus billion analog messages which come to us from a machine. We convert that into a digital meaningful data and we give it back to the organizations for them to use that data to optimize, recreate their process, do the business process refinement, and end of the day, where it needs to head is how do you redefine the revenue streams for those organizations. I think that is the challenge that the industry is missing. What are those pinpoints that you're going to solve for the customer where their operating margins, their revenues grows because of IoT? Now, if you look at the other aspect of it, which Dr. Venkatesh said earlier, at Aeris, we have solutions for farming. In this year only, we announced our solutions for ASEAN and India at farming, wherein we do the entire land analysis, crop analysis, and then on top of it, we also provide an application which can tell a farmer where the machineries are available. He can rent those machineries. He can know what job is happening on my farm, how much job has happened on my farm, and pay it accordingly. From the medical side of it, from the health side of it, we're already providing these services in India. I'm talking about India. We're already providing the services in India where people go into villages and they carry all these tests and then they send it back to the doctors sitting in the cities like Delhi, Bombay, and then the prescriptions and the remedies are sent back to the patients. So what I meant to say is that the use cases are already there. There are companies like us and companies like we who are providing active solution to these use cases. Now the story difference between China and India. China has scale And China, before us, went into the industrial revolution, and we went into the knowledge revolution. That was the difference. I think the time, as Doctor also said, is coming now wherein we should not miss 4.0, because 4.0 is all about knowledge revolution. What do you do on top of that data? What do you do on the data that you get from IoT devices from all across the industry? How do you translate it back into a meaningful stuff for the companies? And last but not the least, how do you use this technology to create more skills, to create more employability? At Aeris, we have that charter as well. How do we train people with those special skills that can bridge the gap? What is the skill needed in the industry and what skills are available? I think IoT and AI spans across all of these: industry, business use cases, and training. If you don't think, as India, if you don't think all these three together, probably the knowledge economy that we are may not be as good as the industrial economy China had. Thank you.
Thanks, Mr. Koul. And I think when Indraneel touched upon the connectivity part of it, probably all of the vertical use cases could be implemented today. But when you talk about a faster data download and upload, which means latency, there you talk about 5G. So 5G is around the corner. Of course, we believe 2020 will be a reality when this commercial system will be rolled out because it has been standardized. But a practical implementations, we expect that to be 2020. But you heard new business models, scaling. I mean, I think, as I said, all the vertical applications can be implemented today. And it has been implemented. I mean, but of course, mass scale has not yet been achieved, and people are just testing the technology. But they're convinced that it will bring a lot of potential. So with that, let me move on to...
Dinesh, I missed one point. Just to be very practical, as Aeris in India, from the IoT itself, we have managed to deliver $10 million of revenue last year. It's not about revenue. It's about telling you that IoT and AI are practical, implementable businesses right now.
Thank you, Koul. Maybe, Indraneel, did we understood connectivity part well, what you had said, or did we miss out? So let's clarify this.
No, so I don't think the at all the point was that connectivity as part of the stack does not matter.
Yeah.
Absolutely, because the ability to unlock data, the ability to do the analysis, and particularly for IoT to be real time, the platforms there. I think the statement, and let me just clarify, is that connectivity is not the only game that's there.
Yeah, exactly.
You've got to build on top of it. So
Stand
corrected.
Makes sense, because 2G, 3G, 4G can do the job. We would need 5G for healthcare, surgery, or a connected car, but technology can do the job. With that, let me move to our second last panelist, Mr. Rahul Ganapathy. Mr. Rahul Ganapathy is the CEO and co-founder of Atsuya Technologies, India's first IoT-based refrigeration monitoring startup, which is headquartered in Mumbai and with a development center in Chennai. Prior to Atsuya, Rahul was heading the IoT solution practice for Cognizant Technology Solutions. He has worked with HCL Technologies, where he was one of the amongst founding member of the IoT practice, holds BTech, Computer Science Engineering, MBA, and credits of filing 4 technology patents in US as well as in India. He has been identified as a Generations Y leader at HCL. Mr. Ganapathy, your views on it.
Thank you so much. So before I start talking about what we do, I want to talk about a real life example of what we are delivering to our customers, and very well in India for a large retailer. I'm sure all of you have ice creams, buy ice creams from retail stores. How many times have we checked whether the pack of ice creams or the cup of ice cream was maintained at between -18 to -22 degrees Celsius, which is the recommended temperature written on the ice cream pack? How many of us have checked if the milk and dairy products that we buy are maintained at 0 to 4 degrees, which is recommended temperature, not only at the point of sale, but throughout the supply chain, from the time it gets manufactured, stored in the factory, it gets moved in the truck, and comes to a point of sale or the retail store, right? The numbers, as Indraneel was telling, on the contrary, I would like to highlight the amount of food wastage that happens in India. We have 35 to 40% wastage that comes post-harvest, primarily due to non-availability of proper storage facilities, especially the cold rooms. I'm talking very specifically fruits and vegetables, to be precise, right? So when we started up a year and a half back, we wanted to really solve some of the very important problems around food safety and food wastage. Now, the answer to that is definitely technology. Okay, so technology, we were able to build a great sensor that monitors temperature that goes into anything that is cold or hot, right? From your biryani counter that is there in a QSR to a retail store where they actually store the imported cheese, right? That doesn't really bring out the value, right? So what is the fun in just getting a timestamp and a temperature noted down, which is today done manually in retail stores in QSR as per the food safety requirements every 1 hour? Can we do something different? Okay, I'm having data collected from these refrigerators using our own sensors that were built in India, deployed, but how do I really show the value to the end customer, right? So that's when we really started working on the analytics and AI-led insights around refrigeration monitoring. So I must say, we are proud to say that we have got significant rollouts made in the last 1 year. And as Indraneel said, a lot of pilots. But the beauty is we were able to convert these pilots into large-scale rollout with quantifiable data and ROI, right? If I were to take a typical large retailer in India we don't have 24/7 operation. The retail store shuts down at 11 in the night, for example, and opens up next day 6. The amount of risk that this particular retailer is into, with nearly 30 to 45% of his sales coming in from frozen items, coming in from refrigerated items. There are cases where there are 5 to 6 breakdowns a week in a refrigerator, and this retailer loses the stock. And he will not be able to use the food at all. So we were able to use analytics. We were able to bring in our own custom process, again enabled by technology, where we are able to collect data from the refrigerators, first connect the refrigerators to the internet, collect data from the refrigerators, made a dumb refrigerator smart, and then pulled out the data to detect and direct a retailer, a maintenance team. And now we are also enabling this data to the end consumer, where you will be able to scan a refrigerator, a QR code on a refrigerator, and find out if that particular food product or the set of food products in that particular refrigerator was maintained at proper temperature. We improved the efficiency of a retail store operation from a maintenance standpoint by 25%. We reduced the food wastage in the order of 8 to 10 lakhs a week for a group of stores in a particular city. And we are now scaling the entire solution backward into the supply chain, and even at the time where it gets manufactured for one of the largest dairy cooperatives in India, right? And all this enabled by data, all this backed by data, by facts that IoT, again, leveraging all the 6 layers of IoT, right from starting from the sensors to the apps and analytics. If we have focus and a good partnership, and it's definitely a partnership-driven ecosystem, I'm sure that there is going to be great progress made in the entire AI and IoT space in the coming years. So I just thought I'll just share this real-life example where we have done this, and we're getting in more projects from various other companies in India around AI and IoT.
Thank you, Ganapathy. Give me a round of applause. It's real case studies in India, which not, applicable for globe, but if you have implemented in India, it will fly anywhere. Once you implement in India, the solution applies everywhere. It's a real case scenario. That's what you can do it with these technologies, and that's where the startup and startup ecosystem could work on. You can do enormous thing with that data which you have it and which you have collated. And this was one of the case study how efficient it could bring that, how much efficiency it could bring to that refrigeration. With that, last panelist is Dr. Hemen Goswami, Vice President Technology Solutions, Infogain. In his present role, he's focusing on unified solution architecture to integrate IoT-driven enterprise data for real-time analysis for retail, manufacturing, and insurance. So insurance is also coming up. Let's hear from him. He also leads the Center for Excellence in Foundational and Digital Technologies to build reusable framework to enhance and optimize engineering services. Prior to Infogain, Hemen worked with a startup organization on data analytics in energy and financial domains, broader domains. He has also worked with GE Transportation as a technical architect, bachelor's in engineering from Guwahati University, MS and PhD both in electrical and computer engineering from Florida. He's involved in with IIT Roorkee and IIT Guwahati in their skill development initiative as well. So let's hear from Hemen, his perspective.
Thank you, Dinesh. So I think most of the points are already covered by the panelists, and that's the challenge for the last person, right? So just briefly to tell you about my company, Infogain. We are a Silicon Valley headquartered company providing platform engineering services and digital engineering services. So primarily our core focus is to build the enterprise platform in order to leverage the enormous data that is being generated by the IoT devices. So in one of our recent applications integrating the IoT hardware device with the actual data analytic, we helped a company in the healthcare domain to build the data analytic platform for continuous glucose monitoring, so that it's a handheld device, and then someone can actually monitor his glucose blood sugar level continuously, and that helps to prescribe the diabetic control medicines. Now, coming back to the overall convergence of IoT and AI, I think IoT and AI are completely, it's almost inseparable, because the whole objective of bringing AI is to make the data into more actionable information, right? Now, I would rather focus more on the enterprise software part, and I fully agree with Indraneel that, see, IoT, I see it as a very complex, multi-layer architecture. If you see the overall IoT ecosystem, you have the hardware, you have a network layer, you have some protocol layer, then you have a software layer, and on top of it, you actually have to build the complete analytic or dashboard, right? So that's pretty complex. And it is complex because of the scale. We are using IoT for connecting billions of devices. It's generating so much of data. So the scale of the problem itself is very huge. Another potential problem that I see, or I don't say problem, I rather say it as the complexity, is IoT is highly distributed architecture. The sensors are distributed everywhere, and that is where IoT is also compelling the overall enterprise system to evolve. And that is why you see a lot of microservices-driven systems which are suitable to handle this distributed type of architecture. And also I see not only AI, if you see at some point of time, we'll see a lot of blockchain technology also to be integrated with the IoT, because whenever we want to have more decentralized data and network management, I believe at that point of time, IoT, AI blockchain, all of them will converge. And convergence of technology will also make it more complex for the technologies, researchers, business analysts to solve the problem in order to optimize the value chain. Now, again, we have a time constraint. I see Dinesh continuously looking at his watch. So, coming back to another point, for example, you talk about the network infrastructure, 5G, 4G, all the kind of issues, and this is the real problem, right? When you go and actually take an IoT solution and try to do it something for healthcare, for example, take it to a remote area, then the infrastructure poses a great kind of challenge. We tried to do some work in energy analytics, we tried to do some upstream oil and gas applications, and in the remote areas, in the rig areas, you don't actually get any network connectivity, right? That's one part. The other part is also, when you talk about the AI in the context of AI, you also talk about the predictive analytic and you talk about the real-time analytic. A lot of time you you cannot wait. You need to generate the analytic on the spot. And so how you create that ultra low latency systems, and that is where computing also now moving more from the cloud to the edge of the devices. So from a software or enterprise software platform perspective, we need to bring lot of computing power from the cloud paradigm to the edge of the device. And we already have seen a lot of commercial vendors coming and they are providing services. The serverless architects are now available on the edge of the device. So these are certain trends that I see, but otherwise I see this something that IoT, the applicability of IoT, I think no one is going to doubt about that. It's already there, but only thing we need to identify what are the best way to leverage IoT in conjunction with AI and all other emerging technologies.
Thank you. Please give me a round of applause. And just before I open the floor, I had a few questions, but time is limited, so let's open the floor for questions. But before I open it, just a comment on Dr. Hemen. I think most of the architectures, when you talk about from an M2M and IoT perspective, are based on RESTful APIs. I think it's more an open system when you talk about, and most of the platform are built on that. In 5G, this is exactly what we are talking about. We are talking about slices. Because when we know there is a massive connectivity will happen tomorrow, we have started talking about 5G as a network slices. For every solution, there is a slice. And on top of it, we are also talking about multi-access edge computing. And you're right, you cannot process the data either in the cloud or in the network. You have to forward that processing power to the last mile. And that's what the standards have been built. It will be implemented as part of 3GPP specifications. So when the 5G is there, it will take care of the massive rollout. But we need not wait for that. I mean, we can roll out the solutions, but massive and latencies and edge computing will happen. So it's coming. With that, let's open the floor for questions. Please ask questions. One hand. And introduce yourself. If you know with whom you are pointing these questions, please inform that.
The question is for the entire panel. Okay. I'm Adarsh, I'm a student, I'm from Hyderabad. And my question is regarding the security of IoT devices. So like Mr. Banerjee said, and another research group has suggested that we'll have 21 billion connected devices by 21. So without having control on the manufacturers in a world where there's so many IoT devices, how do you think security is going to be managed? Like if data is the new oil, then data breaches are the new oil spills, and the consequences are severe. So,
that's a very important point, and of course you touched upon one part of it. There are certain supply chain tactics that are applied where you embed certificates in manufacturing and you have some sort of a gateway. But of late, again, and this is where the AI part comes in, mathematical model on the device signals that are coming in and creating certain models to do anomaly detection, patterns of usage or signals from the device, and using those models to predict that this is probably going under some sort of a behavior which is not legal, not authorized, not planned, and flagging those. In fact, there are some innovative companies that we have used in some of our IoT rollouts in partnership based out of Israel. Completely mathematical and statistical models to detect or predict anomalies in device behavior. Now, that's the other point I was, and slight digression from your question to address maybe some of the solutions that the panel members here talked about. The domain knowledge becomes very important when you apply or roll out AI-based systems. There is the data science part of it. That's where the scientists come in play, and they help us decide or guide on the models to choose, statistical versus CNN models, etc. But the process of feature engineering, how do you train the model? What data set do you expose to the model so that it can behave in a consistent, business consistent fashion? So that is where typically in our IoT AI rollout teams, you would find a composition, team composition. Of course, there would be the software guys who would write scripts and all. But before that, data scientists and domain experts, in an EDG, an emergency diesel generator analytics project that we did for a German company. We literally had two people with extremely valuable industry knowledge from EDG sector. Eventually, they were giving us how to tune the hyper parameters to make the model more predictive, and that applies to security pattern analysis as well. So,
okay, Dr. Venkat.
Yeah, quick, and I can actually tell you in a real life example, right? When I was in US actually, and it was not a security thing, but whole security thing, we had actually 1 million smart meters, right? Basically, they actually, once in a day, the actual electrical meter just showed, a ping. What we didn't know that, that we had tuned that every meter at 12 a.m. woke up and sent it along. So imagine that, it actually brought down the network, basically because everything was at the same time sort of went up and, brought down, bursting. Even though the data was very small, 1 million smart meters actually went up at 12 a.m. and started transmitting the data. Imagine that if that's a security thing, right? Somebody can do this and flood the network. So you have to be very careful how you design and how you protect the thing. It really happened, and we didn't realize, suddenly everything started going down. Then we realized that everything woke up at the same time, and just started sending out the data. So you have to be careful what you do. Sometimes you inherently create security, sometimes you could use it against you.
Yeah, that's exactly, I think you touched upon it. Today, if anybody builds any solution on a standardized technologies, I can tell you, they say security by design. But security is always evolving. It's a beginning. Every day you say it's fixed, actually a beginning. Because cyber threats are the real challenges. So there are various platforms like cyber incident reporting system. Everybody is harmonized, everybody talks about it, everybody tries to fix it. But more and more solutions are ensuring that there is a security by design. When I say it's not fixed, every day there is a new threat. But when the system evolves, technology evolves, solutions also evolves. Anybody has a quick comment to add before we take one more question, because now they are behind me. I would have loved to extend it. Okay. One more question, please. Yes, please.
Hi, good afternoon all. My name is Asim and I'm from Infogain. So my question is more towards business, not on technological front. So as we all know, IoT is an ongoing thing, and there is a huge possibility we are going to roll out many projects in going future. But as Mr. Banerjee said, that we are doing a lot more POCs these days, 10 POCs, 11 POCs. But what restrains, what exactly is restraining companies to go out and roll it, and have real outcomes out of it?
Let me begin with it, and then I'll give it to Aeris. Okay. And then Indraneel. It's high ROI.
So I think the answer is in your question itself, right? Which is, if you are able to prove that there is money coming out of it. The example that you actually heard from Rahul, right? If you go to a retailer and essentially prove in a market, in an industry where margins are single digit, that you can add 1 million rupees to their bottom line per week, the answer is there, right? So our research actually just shows, again, just to frame it in a global context, our research shows that for the 16 lighthouses that we actually covered, right, Johnson & Johnson, Haier, etc., the gap between them and the laggards is such that in the next 10 years, they will have 3 times the cash flow. So these things pay for themselves, right? It's 3 times the cash flow. But there is an initial latency that's there, right? So during that period of time, you need a top-down piece. You need a leader who's basically going to get behind it, invest. You need the right talent. But you need to start with the money. If you start with a cool technology and then say, listen, there could be 5 different cases, I'll figure out where it gets, that is really where the pilot, the pilot trap lies.
I think pertinent is that when you're talking about IoT solutions, you're talking in context of business. As Indraneel said, I'll try and simplify it. It's the problem statement of the customer that you're going to solve. It's not the bag of parts that you're carrying that you want to sell. It's the problem statement. Like our friend said something about temperature. How could they minimize the waste of food? We do a lot of stuff with insurers, how we can reduce their NPA. NPA in financiers and insurers is the biggest problem. The underwriter always revolves around how much am I going to lose. If you go back to them with a solution saying that your NPA is going to come down by X percentage, they're more than happy to pay you X percentage out of that percentage. So I think the business has to evolve from the pain point that you are solving from the customer, not from the, hey, I have this app, I have this solution, I have this device. It'll never, in the IoT world, it'll never fly.
Absolutely. Thank you very much. With that,
Thank you so much.
Close the session. Please give our panelists a round of applause. And may I request, thank you. Thank you very much. And please get hold of them during the break. If you have more
Before we
questions.
close for tea, I would request for chairperson to give out mementos to our speakers. Our keynote speaker, Mr. Dhirendra Kulkarni. Mr. Venkatesh. Mr. Arnab Das. Mr. Indraneel Banerjee. Mr. Ranjeet Koul. Mr. Rahul Ganapathy. And Dr. Hemen Goswami. Now may I request Aarti from Exhibitions India to give a memento to esteemed Chairperson, Mr. Dinesh Chand Sharma, Director, Standards and Public Policy, EU Project SESEI. Thank you so much, sir. Thank you very much.